Welcome to today's lecture on structural analysis. Today we will be discussing on arches and its structural importance. Please look at these figures. These are all indicates the important arch bridges all over the world. Before the cement and concrete or the steel was invented, the arches were there. You can see the old architectural buildings, all are monumental buildings. All historic buildings, we can see we can see arch as an important structural element. This simple sketch shows the technical terms related to arches. These are self-explanatory, so we don't need to go in detail on each. The rise of the arch and at the same time the span of the arch is very important for a structural engineer during the design. Just to have a look on this technical terms related to arches. Now let us see what is the advantage of an arch over a bridge, over a beam, or what special qualities an arch has got compared to a beam. See your left side figure. This figure shows a beam. When it is loaded at the center, it deflects and we have a tension. So this beam is considered as a flexural member. Means it bends, maybe tension at bottom and compression at the top. Whereas arch, most of all the cases, arch is considered as a compression member only. Because the property tension is the one which creates heavy headache to structural engineers. Whereas in compression, it doesn't give much problems to structural engineers, because most of the constructions we do with steel and concrete, where both steel and concrete, they are very good in compression. Look at this case. This shows two simply supported beams. One is loaded at center and the other one is UD load. And from the previous classes we know that maximum bending moment is equal to WL by 4, and in this case when it is loaded with the UD load, bending moment at the center, the maximum, is equal to WL square by 8. What does it show? It shows that this moment is, the first case moment is directly proportional to the span, and the second case moment is proportional to square of the span. You will be experiencing this case most of the practical situations. So what does it mean? If you increase the span, the moment increases by the square of the span. So what does it happen when bending moment increases? When bending moment increases, you will have to provide a beam section, a heavy section, to counter this bending moment. So as a structural engineer, our aim is to reduce the bending moment as much as possible. If it can be 0, that is the best. Let us see for an arch what happens the bending moment at the center. See, this is a typical arch with showing forces. Let us say we have a reaction, vertical reaction, horizontal reaction. Let us say this rise at the center is Y, where the load W is actor, and bending moment at the center C, as we know, W by 2 into L by 4 minus H into Y. So we will get WL by 4 minus H into Y. And whereas in the case of UD load, you will get WL square by 8 minus H into Y. The way as we usually take bending moment. See, here this WL by 4, you can see that it is the same as in the case of a beam when it is loaded at the center. So we call it as a beam moment. Similarly, this WL square by 8 is the same as in the case of a beam when it is loaded with the UD load throughout the span. So what is effectively what is happening here? So when you are providing an arch, this horizontal thrust will create another moment, and that will be in opposite nature, so which will ultimately it will reduce the total bending moment. You can see the total bending moment or the effective bending moment in an arch is nothing but beam moment minus H moment. H is nothing but horizontal thrust. So if you draw the bending moment diagram, this is due to the load. If you are considering it as a normal beam, and this is due to the horizontal thrust H. The effective bending moment, this will be in positive in nature, this will be negative in nature. So effective bending moment will be only the shaded area, that is in blue color. So ultimately the effective bending moment will be reduced considerably in case of an arch. This will be beam bending moment, this will be effective bending moment. So by providing an arch, you can reduce the bending moment considerably. And these are some points related to arches. Long spans beams are not economical, but whereas the arches are economical as bending moment is getting reduced. Okay, that's all with the arches introduction. Next chapter, next class, we'll go in detail about the arches. Thank you.